Problem 4.15. Two links AB and DE are connected by a bell crack as shown. Knowing that the tension AB is equal to 720 newtons, determine the tension at DE and the reaction at C. Okay, first we solve for the tension at DE. We can solve it by using the equation of the moment at C. So moment at C is equal to 0, and using the force at AB, which is equal to 720 newtons times the distance 100 millimeter minus the force DE and the distance 120 millimeter. Equating that, we will get this one, and so FDE is equal to 5/6 FAB. We know that FAB is equal to 720 newtons, so we simply multiply 5/6 times 720 newtons. We get FDE is equal to 600 newtons. Next, we go to B, which is to find the reaction at C. Finding the reaction at C, we know that there is an X component and Y component at the moment C. So we will use the formula, the summation of force at component X is equal to 0. Getting the component X of FAB, we know that -3/5 times the force FAB plus CX is equal to 0. Equating that, we transpose this one to the other side, we get 432 newtons for CX. Next, we get the total force at Y component. We use -4/3 times the force AB, which is equal to 720 newtons, plus the component CY at C and 600 at D. We get 1,776 newtons. Okay, so now we have the X and Y components for the moment C. We can get the C. We use the square root of CX squared plus CY squared. We get C is equal to 1,252.835 newtons. So this is the force. Next, we get the angle. To get that, we have known that CY and CX, we have the C in between of those. We set the angle into alpha. So using cotangent, tan inverse CY over CX is equal to 69.829 degrees. So the final answer would be 1,252.835 newtons, and the angle would be 69.828 degrees.
4.66. Determine the reactions at B and D when B is 60 millimeters. The first thing we should do here is, once we have this figure, we identify the figure, we must find or enumerate the given. Here we have the given wherein B is 60 millimeters and the force acting on A is 80 newtons. Line CB here is 90 millimeters, and in total AB is 250 millimeters. And find the reactions at B and D. The second step is to create the free body diagram of this figure itself. So here we have the free body diagram wherein we created a new right triangle having a y-axis and x-axis here. In total, since we have 250 millimeters and it's already given that CB is 90 millimeters, it is already, this side here is A to C is equal to 160 millimeters, and here we have 160 millimeters plus 60 millimeters. Given that B here is 60 millimeters, then we have 220 millimeters here from E to A. Note that E here is a new point where it's assumed to be there the next thing to do is, once we are already identified the y-axis and x-axis, we have to find the beta, wherein tan beta is equal to 220 millimeters over 250 millimeters, and transposing it on the other side, we have beta is equal to tan here, and then 220 millimeters over 250 millimeters, equating to 41.348 degrees. Now that we identified the beta, we can then move on to the next step and find the force triangle. Here we have the force triangle. The first line here, B, we set the angle to have 90 degrees plus 41.348 degrees from the beta itself, having 131.348 degrees. And here we have 18 newtons, which is the given force acting on A, and the force in the angle given here is 45 degrees. Now moving the force there, we have 90 minus 45 degrees minus the beta itself, which is 41.248 degrees, having 3.652 degrees. Now that we already have the force triangle already solved, we could move on to the next and apply the law of sines and find the B itself, having 18 newtons here, and sine 3.652 degrees equal to beta, which equal to B, over sine 45 degrees. Then multiply each sides with sine 45 degrees, canceling this out. We have beta 800 is equal to 888 newtons. Here we have the D itself, wherein we use the same method to find D, applying the law of sines. D is over sine 131.348 degrees is equal to 18 newtons over sine 3.652 degrees. Multiplying both sides with sine 131.348 degrees should be cancelled here. Then we have D is equal to 942.8 newtons.
Problem 4.69. A 50 kilogram crate is attached to the trolley beam system shown. Knowing that A is equal to 1.5 meters, determine the tension in the cable CD and the reaction at B. So this is our free body diagram of the problem. So this free body diagram is intended to solve for the triangular rule or the force triangle. So since 55-degree angle is given in the problem already, we're going to solve for this angle for this side, so that this length of this side will be used to identify for this side. So by using the SOHCAHTOA, the tangent equation, which is the tangent theta equals opposite over the adjacent side, here the adjacent side is also the same with the 1.5 meter. So opposite side is equal to 1.5 tangent 35 is equal to 1.0503 meters. After that, since we have the length for this side, we can now solve for this side by adding the 1.4 meters plus the 0.4 meters, which is given by 1.8 meters minus 1.0503 meters, which is equal to 0.7497 meters. Since this side is equal to this side, we can now form a right triangle in this side. So the next step will be solving for the beta, which is the angle for the reaction force of the pin B. Since we have already the value for this side, we can now solve for the angle by using the SOHCAHTOA tangent equation. So tangent beta is equal to opposite over adjacent. So beta is simply equals to tangent inverse of the 0.7 497 meters over the 1.5 meter equals 26.56 degree. Since we have already gathered the maybe enough data, then we will be solving for the force of the weight. So to solve that, we're just going to multiply the weight, which is 50 kilograms, times the gravity, which is the 9.81 meter per second squared, which is equal to 490.5 newtons. And after that, since we have already two forces acting, we can now go and use it for the triangle rule or force triangle. Since we have a member CD, so since the tension of the CD is going to be solved, we have now going to solve for the member B, which is the force B. So since we have already computed the weight, which is 490.5 newtons, and we have two unknowns, which is the TCD and B. Since we have given the 55 degrees angle, we can now actually solve for this angle, which is same as this, which is the 35 degrees angle. Since we have computed the beta angle, which is the 26.56, we can just add 35 and 26.56 degrees. So this will be its angle. 26.56 plus 35 is equal to 61.56. 61.56. Since we have already three angles, we can now proceed to law of sines. So this tension for CD is over the sine, the opposite angle of that side will be equal to the 490.5 newtons over the sine 61.56 degrees. Therefore, to solve for the tension CD, 490.5 sine 63.44 over sine 61.56 is equal to 498.95 newton. So this is the tension on the member CD. So to solve for the reaction at B, we'll be going to use the same law of sine. So beta over sine 55 degree equals 490.5 newtons and over 61.56 degrees. Therefore, beta is equal to 490.5 sine 55 degrees over sine 61.56 degrees, which is equal to 456.94 newtons. That's all.
Number 4.141. The pipe ACDE is supported by ball and socket joints at A and E and by the wire CF. Determine the tension of the wire when a 640 Newton load is applied at B as shown. So we have our FBD here. First we're gonna do is we're going to find vector AE. So that is equal to 480 I hat plus 160 J hat minus 240 K hat. Then we find the magnitude of AE using the Pythagorean theorem. That is equal to 460 millimeters. So we find lambda AE next. So that is equal to 480 I hat plus 160 J hat minus 240 K hat over 560. And that when that is in lowest terms, that will become 6I hat plus 2J hat minus 3K hat over 7. Next is we find the moment arm RBA. That is equal to 200 I hat as shown in the figure. That from 640 Newton from the point A to point B, that's equal to 200 millimeters. Next is we find moment arm RCA is equal to 480 I hat. Next is we find the vector CF that is equal to negative 480 I hat plus 490 J hat minus 240 K hat, and the magnitude is equal to 726.7 millimeters. The vector force TCF is equal to the magnitude of TCF times the lambda CF, and that is equal to negative 480 I hat plus 490 J hat minus 240 K hat over 726 times 0.7 times TCF. So the summation of the momentum from A to E is equal to 0. So lambda AE times RBA cross negative 600 J hat plus RCA cross TCF times lambda AE is equal to 0. So using a calculator, it will output a matrix like this. Then it will become like this. So 653.91 TCF plus 384 times 10 to the 3 is equal to 0. So TCF is equal to 587 newtons.